Welcome to our podcast, where we uncover the most important and interesting stories for you. In this episode, we will discuss a solar storm from 2,687 years ago, so massive that its effects are still embedded in trees. A huge solar storm hit Earth 2,687 years ago, evidence of which has been found hiding in tree rings. It was nothing like the storms reported today, and is so rare that only 6 such solar events have been recorded in the past 14,500 years. The last storm of such magnitude happened between 664 and 663 BCE. The unprecedented colossal solar storms are known as Miyake events. Trees reveal a lot about the past, and their rings also harbor stories of massive solar storms that might have hit Earth when there was no technology to record them. A research team from the University of Arizona, led by Irina Panyushkina and Timothy Jull, has been working to study these rings to reveal evidence about solar storms centuries ago. The study is published in the journal Communications, Earth and Environment. Panyushkina warns that if a Miyake event were to happen today, it would have devastating effects. If they happened today, they would have cataclysmic effects on communication technology, Panyushkina said in a statement. The extreme type of solar activity was first identified in 2012 by Japanese physicist Fusa Miyake and named after him. He published his research about massive solar storms and described the distinctive signature of these events. He noted sharp increases in radioactive carbon isotopes, specifically carbon-14, found in tree growth rings, according to the statement. When cosmic radiation interacts with nitrogen, it leads to the formation of carbon-14 in the atmosphere. Later, this carbon-14 reacts with oxygen to form carbon dioxide, which then enters the trees via photosynthesis and gets embedded into the wood. After a few months, carbon-14 will have traveled from the stratosphere to the lower atmosphere, where it is taken up by trees and becomes part of the wood as they grow, Panyushkina said in the statement. The team collected wood samples from dead trees that were found buried in riverbanks, along with timbers excavated during archaeological digs. They dissected individual tree rings and then burnt cellulose from the wood to determine the radiocarbon content. Ice cores retrieved from glaciers and ice sheets also act as time capsules. Every time a radiocarbon spike was detected, the tree ring data was compared to spikes in different isotopes, such found in these ice cores. Beryllium-10 also occurs naturally when solar particles bombard the atmosphere. If ice cores from both the North Pole and the South Pole show a spike in the isotope beryllium-10 for a particular year corresponding to increased radiocarbon in tree rings, we know there was a solar storm, Panyushkina said in the statement. That's all from this podcast. Thanks for listening. We have many more such compelling episodes for you. Enjoy them. Do share your opinion in the comment box and subscribe to us for more.